Hello everyone. I'm from Institute of Aeronautical Engineering College. My name is Pchethan. I'm from CSC department. My roll number is 21951805332. And next, my Tech Talk PPT presentation in data structure subject. And my topic is generating essential primes for a Boolean function with multiple valued inputs. So how does the essential primes for a Boolean function will be used by the help of multiple inputs, multiple valued inputs. And next, what we will learn in this PPT means just an introduction how the abstract multiple inputs used, and next what are the notations, and next generating essential primes, and next detecting essential primes, and next is the uniqueness of the Boolean function, and next the conclusion. So this will be we will going to have. And next first one is introduction. The Boolean function with multiple valued inputs have gained more and more attention due to their application to the design of programmable logic arrays PLAs. In principle, a PLA can implement any multiple inputs switching function. Such a switching function can be treated as Boolean function with multiple inputs. The outputs of the switching function are treated as one multiple valued inputs of the Boolean function. Then minimizing the number of rows of PLA is equivalent to minimizing the number of product terms in the sum of the product expressions for a Boolean function. Next, Boolean functions with multiple valued inputs can be further exploited in designing the PLAs with decoders. A minimized PLA with T-bit decoder corresponding to a minimum sum of products expression for a Boolean function with 2T valued inputs. Next one is given a Boolean function with f with multiple valued inputs as essential prime implicant or simply essential prime is prime implicant of f, which contains a minimum term in which onset of f that is not contained in any prime implicant of f. Generating the essential primes is important in second level logic minimization, since every essential prime must appear in the minimum sum of the products expression of for a Boolean. This research was supported in part by the National Science Council (ROC) under Grant NSC 74 and the Electronic Research and Service Organization (ITRA) (ROC). Next, it has been reported that the Boolean function for the most control circuits have a large can detect all the essential prime at early stages of the logic manipulation process conventionally. Essential primes are generating by the first generating a prime cover for the Boolean function, or even generating all prime implicants. Take the well-known logic minimizer Espresso 11 as an example. This system has a procedure expand implicants into the prime implicants and thus can generate a prime cover for a Boolean function. The detention of the essential prime is in Espresso is performed after the expand procedure has generated a prime cover. And next, such over expanded cube will be called partially essential prime. Then the test is performed to check whether the over expanded cube is actually an essential prime, a necessary and sufficient condition for detecting essential primes for a Boolean function with binary inputs has been known for some time. In the case of the multiple valued inputs, gave a sufficient condition for detecting essential primes. One step further, we shall prove a necessary and sufficient condition for essential prime detecting in the multiple valued case. This condition has been stated in terms of a new consequence operation called the asymmetric consensus and can be tested by using the tautology checking algorithm. Next, tautology checking algorithm is based procedure used extensively in logic minimization and detecting essential primes is one of its application in Espresso. binary inputs, and espresso MB, multiple valued inputs. 141 properties of unfortunate function have been exploited to speed up the tautology checking algorithm. In this paper, we shall consider a more general notation of uniqueness and show that the same result as those for the espresso MB still holds, thus the tautology checking algorithm can be further improved in speed. In section 2, we introduce the notation for multiple value logic minimization. Different consensus operations are defined and compared in section 3. An algorithm for generating essential primes in describing which does not generate a prime cover. The relationship between the algorithm and the expand procedure is also investigated. Then we prove a necessary and sufficient condition for detecting essential prime in section 4. In section 5, the uniqueness of the Boolean function is exploited for tautology checking. Finally, we try to draw some conclusions in last term. And second part is notation. Let us define some concepts in multiple value logic. A Boolean function with multiple valued inputs is mapping. What is a mapping? For P1x and P2x, like that P star x up to P0 to 1x, where Pi is equal to 0 to 1, 0 to pi, means the number of terms which were executed. A generalized Boolean function with multiple valued inputs is a mapping. Here mapping is P1x and P2x, P3x, like that Pnx. Each element of P1, P2, wait a second. Each element of P1, P2, and Pn is called as a minimum term. Minimum term on the set of other set DC set of the generalization Boolean function f and the sets of the minimum terms that have function valued 1 and 0 and d and will be denoted by 1 of and dfs respectively. Note that a Boolean function can be categorized by its on set and vice versa. The next one is cube. A cube is a Cartesian product S1, S and S2S, like that Snx, where Si belongs to P1 from for all 1 to n. The Boolean function associated with the cube is product term. A cube is an implicant for a generalized Boolean function f to Tf of f equal to 9. It is called a prime implicant if T is an implicant of f, then there is no implicant of T of f with T, Gt and T as T. Let C be the set of the implicants of the function f. The C is called a cover for f if T every minimum term and on set of the S is covered by an implicant in C. If every implicant of cover of C is a prime implicant, then C is called a prime cover. Note that a cover for the function f corresponds to a sum of the products expressions of for f. Thus, the two-level logic minimization problem is to find a prime cover of the generalization Boolean function of minimum size. The two different consequences operations have been used for detecting the essential primes 111, but shall introduce a third one called the asymmetric consensus. In the following of the operation will be defined and then compared. Here we can see the simple code which is used by the cubes. And let T1 and T2 be the cubes where T1 equal to S1x, S2x, S3x, like that Snx, and T2 will be R1x, R2x, like that Rnx. The consensus of T1 and T2 is consensus of T1 and T2 U S1 R1. The union consensus of T1 and T2 is U cons T1 and T2. And otherwise, the asymmetric consequences of T1 and T2 is accounts T1 and T2. And here we can see the lemma code. And moreover, T1 and T2 are disjoint in more than one variable, then const T1 and T2 equal to U const T1 and T2 and equal to A const T1 and T2 equal to theta notation. Means mathematical theta notation. Okay. And next, if T is to 2, if T2 equal to 9, then consistent T1 and T2, U consistent T1 and T2, a consistent T1 and T2. Moreover, if T1 and T2 are disjoint in the more one variable, then consistent T1 and T2, U const T1 and T2, and a const T1 and T2 are all equal. Okay. And this is an example. We can see the examples of Boolean function in the form of T1 and T2 means U const, secants, and another inconsistent T1 and T2s. And next one is the uniqueness of the Boolean function. The uniqueness of the Boolean function is binary inputs is exploited to speed up the tautology checking algorithm. In the section, we always generalize the concept of uniqueness to a Boolean function with multiple valued inputs. Let f p1 and p2 up to pn, or if the Boolean function with multiple valued inputs where pi equal to 0 to 1 to pn minus 1, then f is monotone decreasing or increasing in value of j of the variable. It does not exist p1 and p2 such that in this expression. And next, a multiple valued Boolean function which is monotone decreasing in the least a variable of a variable xi is said to be unite in xi. A function which is unite in all of its variables is called to be unit function. Finally, the conclusion is we have to pretend the procedure of pre-expand which can be generate all essential prime without generating a prime cover. This procedure can serve a pre-process of expand procedure and generate part of the minimum expansion of a given cover using the positional cube representation. Pre-expand can be implemented to run in term O, like an example of k dash plus k star, where k is the number of cubes in the given cover for a Boolean function and k dash is the number of cubes in the off cover. Okay, this is my PPT presentation. I think it's over. Yeah, I think, yeah, it's over. So thanks for listening my PPT presentation. I hope everyone liked it. And this is Chetan signing off.